Hello everyone, welcome to this video by Data Science. So we will continue our ADA course, and in the last session we discussed Matplotlib library, which is basically a visualization library, and you try to create various charts for various scenarios and visualize the data in a very good format. And one next library in that series is called Seaborn. So Matplotlib is one library over this, right? So basically, Seaborn is an enhanced version of Matplotlib, I will say. Okay, so in simple words, like whatever visualizations you can create in Matplotlib, they can be done in Seaborn as well. Thing is that Seaborn has a better visualization and it has additional features as well. So in short, this is the difference, and in this video we will look Seaborn for various scenarios, building basic charts which are required for our purpose. Okay, so without wasting time, let's directly deep dive into the concept. So let's start with our first so we'll start with building a histogram in Seaborn. So let's create a histogram. Okay, so how do we create a histogram in how do we do? First of all, we import Seaborn as SNS. Okay, remember, this is how we will basically import Seaborn, because it is an inbuilt library, and SNS is something we have to refer it as like that, but we can change it, as I mentioned always, that it is totally up to user how you want to use it. Okay, we will also import Matplotlib, because at times I would like to show you the visual comparison between the figures that come through Seaborn and that comes through Matplotlib. So matplotlib.pyplot, okay, as plt. So this will be we will be generating some random data. So I'll use numpy for that. Import numpy as np. Okay, so these are the three libraries which we'll need. Remember, this is just an introduction to these libraries. You guys must be wondering that why are we not working on real data? That is because, first of all, I just want to show you what all features are there. Then once we dive into the real data, you will see those things once again, and once you practice them on further case studies, you will remember this forever, right? So that's why I'm doing it in multiple layers, so that you see same things again and again, and then only you will realize that, right? So right now I'm just using random data to just show you how things work. Okay, so first of all, what you will do, let's do one thing. Let's create random. Remember, in histogram we created random numbers. So how we'll do data is equal to np dot random. So what it will do, it will create random numbers. If we do this will create normal distribution. So let's say random, okay, dot rand n. Okay, this will give me a natural distribution. Let's say I want again 1000 numbers. Okay, so this is how I have got the data. Now what I want to do, I want to create a histogram. So create histogram using SNS, okay, Seaborn. So how do you do that? As simple as that. You will go to SNS. In Seaborn there is the method called histplot for histogram. Okay, and so remember what do we provide in this? First of all, we need to provide the data that we have, object that we have created. After that, we need to give a bin size for histogram. How many bins do you want? So bins is equal to 30. Okay, and there's a thing called KD. It means density chart. I will speak about it right now. I'm putting it as false, otherwise by default it comes. So I'll speak about this KDE as well. Now let's say I run this particular thing. So it should be pyplot. Okay, so see, I have got a very good visualization through Seaborn. This is the chart that came. This is the chart that came through Seaborn. So that's how you basically create things there. Now let us say let's try to compare something that we did using Matplotlib. If I try to open that, okay. So let me just open the one that we created using Matplotlib. Yeah, so it was here, and if we just try to look at the histogram that we created in Matplotlib, it is like this. See the difference. Okay, So that is what we are using. Like if I just try to print that thing here only, let's say instead of doing this, I just do plt dot hist, okay, and I provide the same information. Data bins is equal to 30. Okay, let's say I do this, and now I run this, for example, plt dot hist. Okay, see, this is the data that I got through Matplotlib. So of course SNS looks visually better. That's why we use Seaborn for lot of scenarios where you want to have a better chart. So this is the first part of creating normal histogram. Now I will speak about KDE. KDE, it just means a density line. So what you do, that when you do KD equal to true, right? So what it will do, it will create a density line like this to show you how your data is distributed, right? Just to check the density distribution of your data, you use KDE equal to true. So these are the two properties that you should remember in terms of Seaborn. Now let's talk about scatter plots. So let's do some scatter plots in Seaborn. So again, what we will do, we have to get some, first of all, let's get some random data, x and y coordinate. Okay, so let's do x. So let's say x is equal to 1 2 3 4 5 6 7 8. Let's say x is this, and let's say my y is equal to, for example, 3 5 8 13 16, then let's say 22, then let's say 31, something like this. So let me just compare the number of digits that are there. So 1 2 3 4 5 6 7 1 2 3 4 5 6 7 8. So 4. So I need one more number. Let's make it 45. Okay, so we have got x and y, and now what I need to do, simply now plot scatter. Okay, so how do you do that? It is simple. You do SNS dot scatter plot. Okay, that's how you need to write this, and it's simple. X equal to x and y is equal to y. You need to mention that x is equal to x, because this x is variable which you are assigning. Okay, so see, this is the chart that we have got, and this is a simple scatter plot that we have got through Seaborn. So these are the basic charts that we have got. Remember, Seaborn always gives you a better visualization, but it's totally up to choice which library you want to use. I'm just showing you a comparison. Okay, so now we'll move forward. So we created scatter plot, we created histograms, right? And now we'll move towards, in the scatter plot, we will move forward a little bit. We will talk about two more concepts which are called hue and style. So one is hue and second is style. This is something that Seaborn offers, and it is not present in Matplotlib. So what this is, hue means, for example, let's say you have a data of 1000 rows, okay, and it is split into categories 1 2 and 3, C1 C2 and C3. So when you create a scatter plot, it will by default create different colors for each of the categories so that you can easily differentiate. And what is style? For example, in style, it will give different markers to your data points based on groups. Okay, so suppose your data, let's say, is divided into G1 and G2. Okay, so each point which is belonging to G1 will have a, let's say it has a marker like this, and each lying in G2 is like this triangle. So this is what style and hue does to make your visualization little better. So we will continue, we'll try to create a chart on this, right? So let's do one thing. First of all, let's create a random, to understand this, I'll create a random x and y. So let's do one thing. Let's say x is equal to, so we are using numpy, right? So we'll use np dot random. Okay, and there's also thing called choice. So I'm just telling you, there are methods like rand, you can use rand n. Okay, and now you want to create a data, for example. So we want to create categories. Remember, right now I'm talking about hue, for example. So let me show you how to create hue. So in hue, what you need three categories: C1, C2 and C3. So your random data should be distributed in C1, C2, C3. So you need to have those categories. So what you do to create a data with some categories in NumPy is that it's simple. You would say x is equal to np dot random. Okay, first of all you do this, and now you have to so technically random, and after this you do rand, and let's say you created 100. Okay, so first we'll create a normal x and y that we create. Y is equal to np dot random dot rand 100. Okay, so x and y we have created separately. Now if we just run them, we create this. Now what we want is that we want a hue data, and we want a so how will we do? We create a new object, hue underscore data. Okay, so we want to create this particular object. So we again use np dot random. Okay, now we will not use rand because we want to create random data across categories. So there is an option called choice, just which I just showed. So choice. Okay, now what you do inside the choice, you first of all have to pass a list of whatever categories you want to create. Let's say I want to create category C1, or let's say, for example, less income. Let's just name them C1, C2, C3. Okay, for the time being, C1, C2 and C3. So these are the three categories that you want to provide. C3. Okay, this is the list that you have created, and now what you want to do, you want to tell how many data inputs you want. For example, I want 100 rows of data. Okay, so 100 will be split into C1, C2 and C3, and this is what we call hue data. So we have created this. Now let's create a visualization of scatter plot. Just like how did we create scatter plot? Just sns dot scatter plot, right? So what we will do, sns dot scatter plot. Okay, so first we need to do x is equal to x, y is equal to y. Okay, and now what we need to do, hue is equal to, so which is my data for hue? It is this hue underscore data. Okay, we created this particular thing and we just close it. So now if we just try to print this, we will see that my whole data is grouped across C1, C2 and C3, this random data. So see, orange is C1, C2 is green, C3 is blue. So that's how data is grouped in three categories, and this is how it is done. Now there is an additional thing known as style. So that also we can do. For example, let's say I want to create a style underscore data. Okay, I do style underscore data is equal to, and again I'll just follow the above technique, np dot random. Okay, and dot choice. So I want to create pass a list. For example, let's say A and B. Let's say there are two categories of group inside this. Okay, and how many rows I want? Let's say I want 100. So now in this particular, instead of hue, if I just say that style is equal to style underscore data. Okay, I just pass this. See, I have got it created. The color is same, but I have hold my data in two markers. One is normal dot, other is cross. So it shows that my data is split into two categories, A and B. Okay, and I can use both of them together as well. So I'll do hue is equal to hue underscore data. So we can do this part as well. So if you see, this is, it will show me that first of all it is A and B, and inside each category it is split into colors. That's something that you can do, for example, in your particular case. Sorry, so by mistake I removed this. Yeah, So this is something hue and style that you should be remembering. Hue means data across various categories and different colors. It means different markers. Okay, so style means different markers, hue means different colors. I would like to add one thing before we move ahead. For example, in this Seaborn, you would have seen I applied x equal to a, y equal to b. But if you check in Matplotlib, I just used to pass x comma y, right? So let's see what happens if I directly pass x comma y. It will throw me an error. Okay. The reason is that this is how Seaborn is built, that the scatter plot takes from 0 to 1 positional argument, but 2 were given, right? So what you need to do exactly, you need to declare your x and y somewhere and you need to assign them here. Okay, for example, like let's say if I assign them equal to a and y equal to b, then only it will work. Okay, so this is something, this is different from Matplotlib, so you should be aware of this. That's I just wanted to give an update on this. Now let's say I run this. So if I run, I will get my chart. So this is something important to be taken care of, because you might miss this particular small thing. So you know, you might be questioning that why is it that some libraries have different settings, some have different. See, this is the reason why I personally hate libraries, because every library has been built by someone else, right? And they have built as per their convenience. Okay, so this is something that you need to learn. I would say this only comes with practice, but the good thing is that like as you spend more and more time, you will build your own approach, right? That okay, I will proceed in this particular way only. So you might need to remember these things only for once and you will remember them for lifetime. So yeah, I know this is confusing at times, but don't worry about that. It happens when you're learning things for the first time. There are few things which don't have any logic. It's just that they are done the way they are done, right? So that's what we need to understand. So now I will move forward. So now we will continue and we will create a categorical chart. The first one is basically that we are getting is a basic bar plot that we are going to calculate. Okay, create. So in Seaborn. So how is it created? As simple as that. First of all, remember the architecture. You need to create what is a bar plot, right? Bar plot, if you remember, categories and their numerical values. So for example, categories 1, category 2, category 3, and then they will have, for example, sales. Okay, so what you will do, you will create bar like this. So step 1, remember always the step 1 is to create the x and y, that what will be on your x-axis, what will be on your y-axis. Okay, after that simply create that bar plot. So it is called SNS dot bar plot. And remember, as I just explained a few minutes back, that in the bracket you need to pass the variable. So first of all, what is x is equal to and what is y is equal to. This is little different from Matplotlib, where you just need to pass x and y. Okay, so this is something we'll create. And so let me just create a simple data set. For example, let's say we have a categories. Okay, so categories. So let's name the categories as for example, RCB. Okay, RCB. Okay, and then CSK, and then MI. Okay, and then let's do, for example, KKR, and let's do others. Okay, so there are 5 categories. Okay, so what we will do, IPL wins. This will be my on y-axis. Okay, so for RCB we all know it has to be 0. CSK, I think it's 5. MI also it's 5. KKR it's 3. Others, so 5, 5, 10, 13, for example. Let us say assume for others it's 4. Okay, so this is basically what you created, your x and y coordinate. Okay, now what you need to do, you need to simply create SNS dot, here remember in Matplotlib it's bar, here you need to mention bar plot. Okay, and after that what you need to do, x is equal to, and so what is x? X is my categories, and y is my IPL wins. Okay, so Y become my IPL wins, and I will now just simply plot this. So I got my bar plot like this. Okay, so here also you can add those things that we used to add. For example, using Matplotlib, you can add the axis label. So for example, plt.x label. Okay, so what it will be, it will be IPL teams. Okay, and plt dot y label will be wins. Okay, and then you can say plt dot title will be IPL history. Okay, so you can create something like this, and now if I run this, I'll get this like beautiful. I will get this X label, Y label, and title. So this is about using creating bar plots using. So this is bar plot using Seaborn. Okay, don't worry about that. You will have the complete PDF that I create. I'm just showing things one by one to you so that you understand. Okay, so now we will move forward with the other chart. So now we are going to discuss a very important figure that is called as box plot. Okay, you all would have heard or seen something like this somewhere in statistics graph, like where you see you have something like this, and this and this, right? These type of graphs you would have seen. So you must be wondering that, I mean, what the hell is this, right? I mean, what does it even mean? What should I interpret from this particular? Is this even a graph or what? But let me tell you, this is a very powerful graph to basically make out analysis. This is primarily, so let's start. First of all, where is it used? So it is used for two scenarios. First of all, it is used for outlier detection. So we will cover this. So we are covering this in detail right now as well, but we will cover this in outlier detection chapter as well, that what is box plot. Okay, and second is comparative analysis. So what I mean to say comparative analysis is, for example, let us say you want to compare performance of teams A team versus B, right, over, let's say, who scored how many runs, or who scored how many football games goals and all that, or maybe which team had more score, those kind of things. If you have to basically compare two teams, two or multiple teams, so how do you do that? Their box plot is used. So now it is based upon 5 points. I'll say there are 5 points in this particular box plot which we will need to remember. So I will just start the discussion for box plot. There is also a YouTube video on my channel. If you go outlier detection, there also I have explained box plot in very much detail. So let's see what all 5 characteristics are. A box plot generally looks like this. There is a horizontal line like this. So it can be horizontal or vertical both. Right now I'm creating a vertical bar plot. You can just switch it to make it horizontal. Okay. So this is the box plot. This looks like this. Now let us say you have a distribution of scores. There is a variable called as scores. Okay, so let's say there is a variable scores. Now it has, for example, 100 value. So let's say there are 100 students in class, and each student has got some score. Okay, so we have 100 students and 100 scores. Now you know percentile, right? What is percentile? How many percentage of people are below you? That is called percentile. Okay, so here in box plot 4 percentiles are there. Q1, that is 25th percentile. Okay, Q2, that is 50th percentile. I am assuming you guys know percentile. If you don't know, comment below on the video, I will explain that. Okay, Q3, that is 75th percentile, and Q4, that is 100 percentile. So this 4 KPIs will be used. Okay, this is also called median. Okay, you can say median because this is the 50th percentile. Okay, so the first characteristic of any bar plot is your median. So So it is the central value where 50% population lies in, that is drawn like this in this particular box. Okay, so this is called 50th percentile. Wherever you see this line in any box plot, this is called 50th percentile. Okay, the lower line here in any box, this is called Q1, or you can say 25th percentile. Okay, and this top line is called Q3, and this is called 75th percentile. Okay, so remember Q1, Q2, Q3 lies here percentile. Okay, so you distribute whatever your variables are, you distribute them like Q1 is here, Q3 is here, 50th percentile is there. For example, let us say out of 100 students, okay, 25 students had score below 25. So 25 will be your so this will be your 25 will be your Q1, because 25 students have less than that. Similarly, you will have a score here. Okay, you will have a median score of your data. So what is the median of your data? What is the 75th percentile of your data? What is the 25th percentile of your data? Okay, this is that. Now comes this particular difference. Okay, this is called Q3 plus 1.5 times IQR. What is IQR? IQR is this distance. Okay, so IQR is called interquartile range. Okay, this is called interquartile range. Okay, and this is equal to Q3 minus Q1. Okay, remember this particular part. And what will be this? This will be lower, so it is called Q1 minus 1.5 times QR. Okay, this line depicts the minimum value that your variable should have. Okay, minimum value that your variable should have, and this line depicts the maximum value that your variable should have. Okay, so any point in your variable which lies beyond this is an outlier. So any point which lies above this is called an outlier, and any point that lies below this is called an outlier. Okay, so don't get confused, don't worry. Let me just to revise. So let me revise this once again. Okay, so what you will do, let me draw it first once again. So let's say, so this is your bar, this is your box plot. Okay, now this is your normal scenario. Okay, so this is your minimum value, this is your maximum value. That should be, ideally that should be, I'm not saying that this is the minimum or maximum actual, I'm saying this should be minimum and maximum. Okay, so Q1, Q3, okay, and here is Q2. Okay, this is Q1 minus 1.5 times IQR, and this is Q3 plus 1.5 times IQR. So whenever you have to detect an outlier, how do you do that? So suppose you have a variable given score equal to 210. You want to check, is this score an outlier or not? So what you will do, you'll calculate the minimum and maximum score for this variable, min and max. Okay, if this particular 210 is lying on the left side or lying on the right side of this range, then it is an outlier. Okay, so this is the theoretical concept of box plot. Okay, so let's look at this with some example. I think then you will understand it in much detail. So now we will try to understand using an example how to create a box plot. First of all, what we will do, we will take a simple example, we'll create percentiles, and then we will see, we will draw the box plot here. Okay, after that we will use Seaborn to create a box plot directly. Okay, so how it is done, for example, let us say you have a data. Okay, so let's say you have a data is equal to, let's say 88, 90, 92, 94, 96, 90. I'm just putting some random numbers. 95, let's say 84, 107, and then let us say 105, 84, 83, something like this. Okay, let's say you have this data. Okay, now first of all, remember what we want to do. We want to create percentiles. Okay, so calculate percentiles. What all do we need to create? Q1, Q2 and Q3. Okay, so what is Q1? It is 25 percentile. So how does it come? Basically this comes from NumPy. Okay, so what you will do is that percentile 25, this is equal to, it comes from NumPy. So let me import NumPy as well. Import so this is also learning in NumPy also, that how do you calculate percentile using NumPy. So import NumPy is NP, then you will do percentile NP, percentile 25 will be equal to NP dot percentile. Okay, and then what do you need to do? You need to provide the data, that is your data, and tell which percentile you want. We want 25th percentile. Okay, so we will do like this. Now if I just print percentile 25, so the 25th percentile value is 89.5. so let's start drawing this figure for us. Okay, so if I have to create the box, the minimum, this value is 89.5. okay, now let us say I have to calculate 50th percentile. Okay, so 50, so let me just add couple of things. 50, 75. Okay, so we'll calculate 50 and we'll calculate 75. So 50 and then we will do 75. So here I'm going to do 50 and 75. Okay, so let's see what all percentile come. 89.5, 94.5, 98.5. So Q2 is 94.5. So if you see, if I have to create the box here, box will look like this. Okay, and this is median value of the data, that is 94.5. and what is the upper the Q3 value? Q3 is 98.5. okay, 98.5. so can we calculate Q3 minus Q1? Yes, so let's do print percentile 75 minus percentile 25. Okay, so it is 9. So this thing, interquartile range, that is IQR, is equal to Q3 minus Q1, which is equal to 9 here. Okay, so this is 9 here. Now what we need to do? We need to find the minimum and the maximum value. So what will be the minimum value? So minimum value will be, if you remember, minimum value will be equal to Q1, that is percentile 25 minus 1.5 times IQR, that is so let's say IQR is equal to this. Okay, so IQR will be my this, and what will my maximum value? Will be equal to percentile 75 plus 1.5 times IQR. And now let's print minimum and print maximum. Okay, now when we do this, we got minimum 76, maximum 112. Okay, so minimum value will come down here, this will go till 76 and the maximum value will go till 112 that this data can take. Now any value that is less than 76 or any value that is greater than 112 is an outlier to this data. Okay, for example, now a new student comes, says okay, his score is 120, so you will say this is an outlier to this data and let's remove it. So this is how outlier is identified and this is how box plot is created. So now instead of this, let's start creating a simple box plot using this. Okay, so I hope this much is clear. So what we will do, let's say we have this data equal to here. So let me just copy it. So let's see if the same distribution comes or not. Okay, so what we will do, SNS dot box plot, and then we will give data is equal to data. Okay, this we will give. Now let's see. Okay, import Seaborn as SNS. Okay, it should be box plot. See, this is how it is created. So if you see, the minimum value is somewhere around this 80. How much we had? 76, right? So it is 76 is the minimum value, highest is 112, and 90. What was IQ3? Q3 was 98.5, and Q1 was this. And this is how things are created. This is how a box plot is created. Okay, so I hope this explanation is clear. Now we will move towards a practical example of comparing. Now remember, I told you box plot is used to compare values, right? So now we will talk about the second thing in the box plot, that is comparison, how you can compare the data, right? So if you see, the box plot gives us median value, okay, and the minimum and the maximum value that it should have ideally, right? It gives a distribution. So basically it gives the interquartile range, and it gives me the minimum maximum value. For example, let's say there are two variables, A and B. Okay, you want to compare them. So what you can do, you can simply create their box plot, something like this, or on a parallel scale, and through this you can see that, okay, for variable A my median value is higher. Okay, I can say that. So my variable A has a higher median, it has more tendency towards that. Then we can compare in IQR. We can say that let's say IQR of A is less than IQR of B. So we can say that it is the data for A is clustered to around the centroid, right? But the data for B is not clustered towards the centroid. So that is something you can infer. Then you can infer the min max value, right? So these kind of analysis we can do. We will read about them. So we'll see what all insights we can build. For this, I have taken 3 data sets for you guys. Let's say we have scores of 3 teams, team A, team B, team C. Okay, now we want to create a box plot using for these 3 in a single chart. If I want to create box plot of these 3 data in a single chart, what I will do, I'll create a single list. First of all, data which is equal to team A scores, team B scores, and team C. So I'll say 1, then team B scores, okay, and then team C scores. Okay, so we'll create a simple list like this and run this. Now just try to, let's see how my data is looking like. Print data. Okay, so if I print data, so my data is a list basically, right? It's a list of lists. So that's all I have. And what is my category? So my category will be, so team, you can say that team names is equal to, you can say A, you can say B, and you can say C. So let's say we have these 3 teams. Okay, now you want to compare their data. So what you will do simply, so first of all, your first step, right, is to create, remember we create a white space, create a figure space for the, because whenever you're entering multiple charts in a single, you have to create a figure space. So how do you do that? You have Matplotlib, right? So you will do plt dot, you create a figure. If you remember this, we did this in the last matplot session as well, figure, because whenever you're entering multiple charts, you need to give a figure. So let's say fig size, I will give a random size is equal to, we can give it as, for example, 10,5 or 10,6, for example. Let's say we give this. Okay, now we'll simply create box plot in this particular fig size. So what I'm doing, I will do that. So SNS dot, okay, box plot, and I'll put data is equal to data. So it's as simple as that. Now I got an error. PLT is not defined. Okay. I need to import Matplotlib. So import Matplotlib as dot py plot as plt. Okay. So now if you see, we have got three teams, team A, team B, and team C, and we have their for example, we have got their respective things. Okay, so team A, for team A I have the box plot, team B I have the box plot, and team C I have the box plot. Now how do you read about this box plot? Okay, that is the point, that what is the inference that you can withdraw. So let us compare. So we see that, first of all, let's compare the central tendency. If we see that central tendency of team A and team C, it is way higher than team. So for C, central A tendency is higher, like median is higher than B, then sorry, C is greater than A, which is greater than B, right? Okay, so this is something that we can see. For C, it is the highest median, and if we see, it has the least interquartile range here. And team A, if you see, it has a very wider outer interquartile range. Okay, so for outlier, you can say if any point greater than this or lower than this is an outlier here. Same for this. Okay, now if I have to do comparison, I can say that team B consistently scores lower than team A and C, right, as we just saw. So this is an initial, like without doing any sort of analysis. I plotted my box plot and I was able to compare three variables in one chart. Okay, this is something very interesting. And team A and comparatively better, and team C is like the more consistent, which we just talked about. So this is something that you can you can change the labels here, like 0 means team A, B, C. You can change these labels. So we discussed that, how to do that. So main thing is to develop insights out of this and understand what box plot does. So remember, box plot has two applications which we just discussed. The first one is to calculate the outlier, and second one is to get the comparison. There can be more attributes as well, but we will see as they come. But these are the two major ones. So that's about the box plot. Now I will move ahead with the next topic. So now we come to the last visualization, and it is one of the most important as well, that is heat maps. Okay, so I'm sure you would have heard somewhere. What are heat maps? Basically, they are square matrices, right, where you have all the values listed in small rectangles or bases, okay, or squares. And what you do, you actually color code them depending upon like how close they are. So for example, let us say there is a value of, let's fill this 1 2 3 4. Okay, let's say 1.1, so 1.15, 1.09. okay, and let us say again 0.9, 0.8, 0.92, 7.6. okay, and similarly 1 again, then let's say 1.1, 1.05, 1.03, and 1.02. So what are you seeing is that the numbers which are closer, so what you decide a color range which varies from a basically color palette, for example white to red, okay, or let's say green to red, okay, green to red, and you define that particular thing, green to red. So numbers that lie, for example, if you see most of the numbers which are around 1, they will be somewhere around so it will start with the lowest number, which is 0.8. so it will have some light version of green. Then as it move ahead, right, it will start having the intensity of green color will start increasing, okay, and this, and the moment it reaches 3 or 4, so it will become little darker red, and the moment it reaches 7.6, it will become very red. So what happens that you create a color pattern, color saturation, as the number vary from a particular number to other. So we will understand this. What this helps is, actually it helps in analyzing the correlation between the variables, how variables are correlated to each other. So basically two colors who belong in the same color zone, right, they will be belonging to, they will have a similar type of feature. So that is what the interpretation is, that if two variables have the same color zone, they have similarity. Okay, so that is what we infer. We will be using heat map very extensively in our course. So now let's try to create a basic heat map. So what do we do? Let's create a simple matrix of numbers. So we use some random values. Okay, so np.random, and we'll take dot rand. Let's say create a 2x2 matrix. Okay, 2x2 matrix. So what it does, this will create a 2x2 matrix to me. Now after this, what I have to do is SNS dot heat map I have to call. Okay, now I have to provide the data first, that is matrix. Okay, then annotation. Annotation means you want to place the value of the cell in that particular map. For example, what is this value? If you write this value, means you are saying annotation yes. Okay, so annotation equal to true. If you put it false, it will only show color, not the value. Okay, and then you want there are multiple color palettes. I'm using Coolworm. There are like lot of, we can check it while later in the course. We will see lot of color palettes. Okay, so simple. This is a simple numpy.random. Okay, sorry. So see, I have got four numbers: 0.28, 0.62, 0.65, and 0.94. So if you see this number is varying from dark blue to dark red, and this is the color palette. So the lowest number is blue. Then as it moves toward 0.62, these two colors are similar, means these two values will be of similar scale, and 0.94 is beyond that scale. So you can increase. For example, let's say you want 5,5. Okay, a bigger matrix will look like this. So things which have similar color, you can club them together. This is what heat map does. Let's say you have 300 variables. Okay, and you want to analyze, okay, 300 properties. You want to know which properties are together, which are not. So there you use a heat map. Okay, so we will be using them very extensively in coming classes. So here I'm just showing you that what a heat map looks like. So that's about the heat map. I think we are done with the thing. Now after this, you will have a basic assignment, right? So yeah, I mean, you have a basic assignment after this session. So just complete that and submit on the time. And with this, we complete Seaborn, and this we complete our 4 major libraries that are present. See, there are a lot of things in libraries. If you say I have covered everything in Pandas, Matplotlib, no, I have not. And to be honest, I cannot. Like if I start covering Pandas or Seaborn completely, it might take me like 8 to 10 hours at least, one video, right? So that is not useful. We just need to know what all basic visualizations are there, because we will be doing data analysis using these things. Okay, so these are the major things. Like someone might come say, okay, you didn't cover this type of graph, that type of graph. Like I have covered everything that is required, and if something comes during the course line, I will cover them. Okay, so that is the part. Now we will move from the next video onwards, we will move towards the whole machine learning pipeline, and we will see what are various data. So major things are data pre-processing, data collection, data pre-processing, building the ML model, validating the ML model, and then we will move towards 2 projects. Okay, so that's about this video. I hope you like this video, and if you like, please subscribe and share this video, and I'll see you in the next one. Have a good day.